So Parag, thank you for joining us for the Open RAN Forum 2022. I'm excited to hear from you about the work that Saankhya Labs is doing. So maybe to start with, we can talk about the challenges that operators are going to face in moving from some of these smaller, more limited deployments of Open RAN infrastructure to scaling up across national macro networks.
Yeah, thanks, Sean, for having me here. I think Open RAN is the fresh breeze of wind in some sense. You've got this new diverse ecosystems that's coming up. On the remote unit side, on the RU side, you've got a diverse bunch of new players that are coming in. But however, on the DU side, you have much limited diversity, right? And that results in lower TCOs and also lower performance. So I believe that one of the things that you would need for really massive scale Open RAN deployments is custom silicon and onboarding of custom silicon that give you the best performance for the network. And the other important aspect that I want to bring out is as there's more cloudification of the network and there's a virtualization of the network, the layer 1 RAN on the DO side is still not completely virtualized like it should be. And that's one of the challenges that I see in mass deployment of Open RAN.
So when we have these conversations about Open RAN, it's very important that we also keep in mind some of the larger movements around taking telco network workloads and putting them into cloud environments. So in this context, what do you think operators need to do to leverage some of the best practices developed in the IT world and port those over to telecom to really make these networks more intelligent, adaptive, and optimized?
Sure, interesting point, Sean. If you look at the way IT clouds have evolved, the fundamental concept there is to take a canonical resource such as a compute, storage, or networking, and manage them. And once you treat something as a resource, you can now slice and dice it, pull it together, and have an orchestration like platform like Kubernetes or any other management platform that allows you to pool these things. So if you look at storage, the way it's evolved in a typical data center is it's gone from being server attached to network attached. So then you're basically converting a lot of north-south traffic into east-west traffic, and that allows you now to get scale independent of the server. And if you look at a telco cloud, the only difference between an IT cloud and a telco cloud, apart from low latency and high bandwidth considerations, is the RAN compute. Right, the RAN compute is basically fundamentally a very different resource. And right now we are not treating the RAN compute as a resource on the telco cloud. The ability to take this important piece of resource and treat it as one and slice it and dice it and manage it like the way you do other resources like CPUs or GPUs or storage in an IT network will differentiate the telco cloud there. Basically, the ability to virtualize and decompose the RAN environment. That's the thing. What it allows you then is you kind of have a network attached DU eventually, which means you could have pools of RAN compute that are now managed by a common management software that's not possible today.
Towards the beginning of our conversation, you mentioned the importance of custom silicon and helping operators scale up their Open RAN deployments. I'd love to hear a little bit about what you and your colleagues at Saankhya Labs are doing to disrupt this space. What are some of the new concepts that you're putting into market?
Yeah, there are fundamentally three major concepts that we're introducing to Open RAN, and some of it is also being brought into Open RAN working groups for standardization. One of the first ones is a concept that we call the RAN visor or the portable RAN framework. Now, this I just spoke about treating RAN as a resource, right? How do you do that? You need to have in some sense, we call this the RAN visor, the RAN hypervisor, a hypervisor that actually brings in one level of indirection between the hardware and the software. And this vertical decoupling or vertical disaggregation that we call it allows you to now onboard custom silicon and also move across a plethora of hardware platforms. So today, if I have a DU vendor and I'm stuck to one particular DU hardware, right? So for the DU stack vendor to move across different hardware is almost impossible. So that's one of the big innovations that we're being introducing to Open RAN. The second one is a concept of vertical scaling. So like I also said, the ability to pool RAN compute, right, and the ability to run multiple modems, multiple RAN instances without having to worry about where that instance runs and how the compute is allocated to it is something that that we are bringing to the fore. And what are the advantage of this for the operators? You get high pooling efficiency, which means you need fewer RAN compute resources. It allows lesser fragmentation of RAN resources and therefore better pooling. You could go to what I call the provision on the go. So today, provisioning for any RAN compute is done for the worst case scenario, right? And then it's fixed. You're not able to dynamically put in, RAN compute. So think of it like, a network attached storage. So similarly, you could have an Ethernet-based DU stack that you just put it into the network, and then you can run more RAN modems. So today, you have to actually bring in a server plate if you want to run additional RAN compute or deploy additional RAN compute on the on the network. And third and final one is a concept that we call radio mapping. It's a way to digitize the radio environment, much like Google Maps digitizes traffic and the roads, right? So you create maps, so-called radio maps, and once you have these radio maps, you actually ingest that data into the network and allow AI/ML techniques to be now applied for all the RIC frameworks that are prevalent today and all the XApps and the RApps that run. So this exploits the fundamental nature of the RF environment, which is that it is a very, very fast moving commodity. An RF environment changes every few milliseconds, if not lower. And then you have to have networks that actually react to it. So today, as networks are statically provisioned, right? So you have things deployed for the worst case scenario, that networks are provisioned such that everybody sees a bad channel. Everybody is moving at say 100 miles an hour, and everybody has a lot of interference. So you waste a lot of spectral resources because of that. And therefore, a technique like radio mapping allows you to now do network automation in a much better way, and also better use the spectral resources, everything else being said. Those are the three major key innovations that we're bringing to Open RAN, and we believe all the three of them would help the operators and the ecosystem to actually be able to scale Open RAN to the heights that it's supposed to go to.
Well, it certainly is a dynamic time for the telecom sector. And Parag, I appreciate you sharing your perspective and telling us about the work you and your colleagues are doing. It's great been having you here at the Open RAN Forum.
Thank you, Sean. Pleasure talking to you. Look forward to more such conversations.